A while ago, I bought a Hornby job lot from eBay, and it included this R126 car transporter. Now this one, because it came with the Sierra cars, presumably dates between 1991 and 1996. So it's been around a while, and it's showing its age because it's lost some of its railings, and it's lost one of its loading ramps. Now, I've got a 3D printer, and I find it very useful to print spare parts that are no longer available. So what I've done is to print railings and a loading ramp. And what I'll do in the next few minutes is show you how to do this using Openscad and a 3D printer. As I say, I like to use Openscad because it's a scripting language, and I'm a retired software engineer, and I find it keeps the brain going, and I find that it helps me to build replacement parts that just are no longer available. As I say, this thing's from the early 1990s. I'll be back in a minute. Okay, so here we have the finished item. We have one loading ramp which articulates just like the old one, and a complete set of railings. Still looks a bit like a toy, but at least now it's a complete toy. If you've got this far, that's great. Thank you very much. Thanks for watching. The rest of this video will be looking at Openscad and just how to implement this design on a 3D printer. Let me go to the other setting, and I'll see you in a minute or two. Cheers. Okay, so let's start with trying to make the ramp. What I want to do is start off with a box about the same size as the ramp, and then I want to turn it into the sort of wedge. So in Openscad, what I'm doing is I'm using the difference function, which basically subtracts one shape from another. So I'm taking the box shape, which in Openscad parlance is a cube, and that's the dimensions of the cube. And then I'm rotating another cube and subtracting the two. Or rather, subtracting one from the other. I can then make some cutouts by again performing a difference with some cubes. So I remove these sections. And then the other cutout on the other side by a similar method. In this case, I'm slightly angling the cubes to match the top surface of the ramp. And then finally, I'm adding in what I refer to as the internal walls, and adding on the hinges. And there we have our loading ramp. When it comes to the fence, I've taken advantage. Well, let's start with the basic fence. The the fence is a multiple of one vertical upright and then 3 horizontals, and that's basically multiplied 1, 2, 3, 4 times with an extra vertical on the end. Now I've used the Openscad function module, which basically allows me to reproduce a piece of code over and over again. So it stops me having to write all these bits of code here over and over again. So all I need to do is instead of everywhere that I need to use these lines of code, which give me a vertical and 3 horizontals, all I need to do is call the function panel. So what I'm doing is putting a panel there. I'm then translating it a little bit, moving along the axis, adding another panel, and then so on until I get the whole thing done. Then finally, on the end, I'm putting a couple of I'm putting the extra upright. Now, because of the shape of the cutouts in the base of the car transporter, I'm taking advantage of these little areas here. There are 2 circular holes, and I'm just putting a semicircular piece of PLA in there to help support the fence. And there we are. All we need to do is translate it into an STL file and then print it. So in Openscad, if we first of all print render to produce a final version of the model, there we have it. And I can produce an STL, which I've already produced. The STL can then be used with a slicer and printed on your particular 3D printer. So, right, if you've got this far, thank you very much. Thank you for watching. All the best. Bye.